Problem 2. In quadrilateral PEAR, PE is 21, EA is 20, AR is 15, RE is 25, and AP is 29. What is the area of the quadrilateral? As you can see in this problem, there is no picture that is given, and only it gives us some side lengths, and we know that it is a quadrilateral. Other than that, we don't know what the quadrilateral looks like, what its angles are, so and so. So there's a lot that is missing from the problem. Here's how we can solve it. Whenever you see that the problem is giving you some conditions, but all of these conditions are very vague, such as, oh, it's a quadrilateral, but we have no idea if it's concave, convex, anything like that, it means that those conditions are not necessary to solve the problem. In other words, the figure that we can draw from these conditions can be any shape we want it to be, as long as it fulfills all of these conditions. So the quadrilateral could look like this, it could look like this, it could look like anything we want it to be. But in order to make everything as easy as possible, let's make it into one of the simpler quadrilaterals, like a rhombus, a square, a rectangle, or a trapezoid. As you can see, it will definitely not be a square, rectangle, or a rhombus because we are given its sides. But what we can give it is turn it into a trapezoid, because the only thing that defines a trapezoid is it is a quadrilateral that has only one pair of parallel sides. And those sides can be any length we want it to be, as long as it is parallel. There is one parallel side. So let's take a look and see how we can draw this. Well, I'm going to start with PE. So let's draw PE right here. And we'll label that 21 and PE. And I'm going to make this the top side of the parallel set. So this next one will be 90 degrees, just because that's easier. And we'll make this 20. So that's about 20. And AR is 15. So we have to make it a little bit shorter. So AR maybe here. And look, it doesn't have to be super accurate, right? Because as long as we know it's two right triangles and it's a trapezoid, it's all good. And we don't know what is the length of RP, but we can still connect it. So we don't know this side length. Now what it says is that AP is 29. So that's the diagonal between these 2 points. AP is 29, and we know that RE is 25. So we know that this is a trapezoid, right? And that these two sides are parallel. Now using this figure, how can we find it? Now we have drawn our quadrilateral PEAR, which in our case also happens to be a trapezoid. But it doesn't really matter in the end, whatever shape it is, because it fulfills all of the conditions that the question has given us. So again, we can think of it as if the conditions are really little or very vague, it means that those are the only conditions we have to worry about. So we don't have to worry about anything else. We can even add new conditions, but the thing we can't do is subtract conditions. Now we can find the area of this trapezoid. And this method and this way of thinking that we used here is called engineer's induction. So let me write this here. This is called engineer's induction. And engineer's induction is a type of thinking that we can apply not to just geometry problems, but lots of different problems in lots of different cases. So it's basically saying when there are very little conditions, when conditions are very little or vague, we can substitute in and think about it in terms of a very specific or extreme scenario. So in this case, the scenario that we came up with was not just any quadrilateral, but a special type of quadrilateral that we knew how to find the area of, which was a trapezoid. Because the question didn't specify what type of quadrilateral it was, a trapezoid is still a quadrilateral, so that's what we decided to do. So we substituted in a very specific scenario. Obviously, this is very hard to explain because you could do it in any type of problem. So in the engineering field, this is something that you will use a lot. Anyways, now we have the figure down, so all we have to do is solve. So the area of a trapezoid is 1/2 times the upper side plus the bottom side times the height, which in this case is 1/2 times 20 times 21 plus 15, which is 36. So this gives us 360 in the end. So our final answer in the end is 360.